What if everything you thought you knew about science is wrong? Long before Newton saw the apple fall, before Einstein imagined time bending, there were ancient minds, forgotten by textbooks, who cracked the secrets of nature using nothing but logic, stars, and stone. They didn't wear lab coats. They didn't have equations. But they observed, experimented, and changed the world forever. So, who was truly the first scientist in human history? Stick with us, because the answer will take you across 5,000 years, through temples, scrolls, and stars. Backhand Index Pointing Right subscribe to History Vault, and uncover the truth they never taught you in school. More than 4,000 years ago, long before the term scientist ever existed, there walked a man in ancient Egypt whose influence continues to echo through time. His name was Imhotep, and he lived around 2650 BCE, during the reign of Pharaoh Djoser of the Third Dynasty. Though modern textbooks often overlook him, Imhotep is considered by many to be the first recorded polymath in history, an architect, physician, priest, astronomer, and philosopher. In a world dominated by superstition and myth, Imhotep stood apart because of his ability to interpret nature through logic and observation. He didn't just build monuments. He built systems of thought. Imhotep's most famous achievement is the design and construction of the step pyramid of Djoser at Saqqara, the world's first large-scale stone structure. But what's even more incredible is that this monument was not only an architectural marvel, it was a symbol of organized knowledge and planning. Building such a structure required a deep understanding of mathematics, geometry, material science, and engineering principles, concepts not even formally defined at the time. He used trial, error, and perhaps even early versions of scientific reasoning to innovate in construction. His design set a precedent for the pyramids that would follow, but his genius didn't stop at architecture. Imhotep was also a healer, a medical practitioner whose writings became foundational texts in Egyptian medicine. The Edwin Smith Papyrus, though written centuries after his death, is believed to be based on his teachings. It offers logical and surgical approaches to trauma and disease, describing diagnosis, prognosis, and treatment in ways that show Imhotep's efforts to separate medicine from magic. He treated wounds, reset bones, and identified organs, often relying on observation and experience, not divine intervention. That made him a revolutionary figure in a society that viewed illness as a curse from the gods. Imhotep's intellectual influence was so profound that after his death, he was deified, a rare honor for a non-royal. Over the centuries, temples were built in his name. The Greeks later identified him with their god of medicine, Asclepius, and even kept statues of Imhotep in healing temples. To be worshipped as a god of wisdom and healing long after death is a testament to how far ahead of his time he was. Perhaps the most astonishing part of Imhotep's legacy is how it reflects the earliest sparks of the scientific method. He observed problems, formulated solutions, experimented with materials, and documented knowledge. This is the essence of science, and Imhotep practiced it before the age of iron, before formal education, before telescopes and test tubes. He exemplified the idea that knowledge could be accumulated, improved, and passed down. And for a civilization that built itself around the afterlife, Imhotep gave Egypt a legacy that lived far beyond the tomb. He didn't wear a lab coat or use Latin terminology. He didn't work with microscopes or thermometers. But Imhotep embodied the curiosity, discipline, and rational thinking that would become the backbone of scientific inquiry thousands of years later. He reminds us that science is not limited to modernity. Its roots are ancient, and its earliest practitioners, like Imhotep, worked not in laboratories, but in temples and stone courtyards, driven by wonder, logic, and an unshakable desire to understand the world around them. More than 2,500 years ago, in a world ruled by myth and superstition, there was a man who dared to ask a different kind of question. His name was Thales of Miletus, and he lived in ancient Ionia, in what is now modern-day Turkey. While most people believe that gods controlled the winds, the seas, and the stars, Thales chose to believe something radically different, that nature could be explained not through divine power, but through logic, observation, and reason. That single idea was not just revolutionary. It was the beginning of science as we know it. Thales is widely regarded as the first philosopher in Western history, but he was much more than that. He was a mathematician, an astronomer, and perhaps most importantly, a natural scientist in the purest sense. He sought explanations that did not rely on mythology. For example, while his contemporaries said that earthquakes happened because Poseidon, the god of the sea, struck the earth with his trident, Thales proposed that earthquakes might occur because the earth was floating on water and could be shaken by waves. Was this idea accurate by modern standards? Not really, but the method he used was absolutely revolutionary. He tried to explain a natural phenomenon using a natural cause. That alone set him apart from nearly every other thinker of his time. One of Thales' most remarkable accomplishments was a prediction of a solar eclipse, which is believed to have occurred in 585 BCE. Ancient sources like Herodotus claim that this prediction caused two warring armies to lay down their weapons in fear and awe when the sky darkened at midday. While scholars still debate how exactly Thales predicted the eclipse, the event itself became legendary. It demonstrated that celestial phenomena could be understood and perhaps even predicted, not feared as mysterious punishments from the gods. Thales had pulled back the curtain, if only slightly, on the machinery of the universe. Thales also introduced the idea that everything in the universe came from one basic substance. According to him, that substance was water. While modern chemistry has of course moved far beyond this notion, Thales' idea was groundbreaking at the time. He wasn't just guessing. He looked at the world around him and noticed that water was everywhere, in rivers, in rain, in living things. He concluded that it must be the fundamental element of all life. The logic behind his conclusion was simple, even childlike, but it was also observational and rational. Thales was not interested in rituals or divine origins. He wanted to know what things were made of and how they worked. Beyond physics and cosmology, Thales contributed to mathematics. He is credited with several geometric theorems, including what's now known as Thales' theorem, which states that if A, B, and C are points on a circle where line AC is a diameter, then the angle at point B is a right angle. This principle is still taught in geometry classes around the world today. Thales used geometry to measure the height of pyramids and the distance of ships from the shore. He did this not with instruments, but with reason and ratios, simple tools in the hands of a brilliant mind. But perhaps the most important contribution of Thales wasn't any single discovery or theory. It was his approach. He believed that the universe was something we could understand through our senses and our minds. He set a precedent for asking questions that sought logical, testable answers. His influence was so profound that even Aristotle, writing 2 centuries later, regarded Thales as the first person to offer a natural explanation of the world. In a time when myths were treated as facts and gods were given credit for every mystery, Thales lit a tiny flame of reason. He questioned tradition, defied superstition, and believed that the universe was governed not by chaos or magic, but by order and law. That belief would inspire generations of thinkers after him, from Pythagoras to Galileo, from Newton to Einstein. The scientific method, the cornerstone of modern science, begins with a question, and the first man to ask that question with courage, in recorded history, was Thales of Miletus. He didn't have a telescope. He didn't have a laboratory. All he had was his mind and the courage to use it. That's what made him the father of rational science. Not because he had all the right answers, but because he dared to look for them in the natural world and not in the heavens. In the ancient Greek world, a man emerged whose vision of the universe was unlike anything seen before. His name was Pythagoras, and while most people remember him only for a simple geometric formula involving triangles, the depth of his thinking went far beyond schoolbook math. To Pythagoras, the universe wasn't just made of matter or elements. It was made of numbers. Everything, from the orbits of the planets to the notes in a musical scale, could be explained through mathematical relationships. It wasn't just science to him. It was sacred. In fact, for Pythagoras, mathematics was a divine language of the cosmos. Pythagoras was born around 570 BCE on the island of Samos. He later traveled extensively to Egypt, Babylon, and perhaps even India, absorbing knowledge from the most advanced civilizations of the time. By the time he returned to Greece and established a school in Croton, Italy, he had developed a philosophy that combined mathematics, spirituality, music, astronomy, and ethics into a unified system. His followers weren't just students. They were part of a brotherhood that lived by strict rules, studied in silence, and believed that learning numbers brought them closer to understanding the soul of the universe. What set Pythagoras apart was his belief that numbers were not just tools. They were the essence of reality. He observed how strings of certain lengths produced harmonious sounds, and concluded that music followed strict mathematical ratios. This led him to declare that harmony, proportion, and order governed all of existence. His discovery that a vibrating string produces tones that relate in simple numerical ratios was more than a scientific insight. It was the beginning of what we now call acoustics and wave theory. But it didn't stop at sound. Pythagoras extended this logic to the heavens. He proposed that the planets and stars move according to mathematical equations, producing a kind of silent music, what he called the music of the spheres. Though no instrument could capture it, he believed that this cosmic symphony was proof of the universe's mathematical perfection. The idea might sound poetic, but it was rooted in observation and reason, and it planted the seeds for what would later become astrophysics and celestial mechanics. Of course, Pythagoras is best known today for the Pythagorean theorem, a superscript 2 plus b superscript 2 equals c superscript 2, which describes a relationship between the sides of a right-angled triangle. But to Pythagoras and his followers, this wasn't just a formula, it was a revelation. They saw this elegant mathematical truth as evidence that numbers held the power to unlock the structure of space itself. Geometry wasn't just useful, it was a spiritual pathway to understanding the cosmos. His school also made advances in mathematics that laid the foundation for future generations. They studied prime numbers, odd and even numbers, and developed early forms of mathematical proofs. The concept of irrational numbers, numbers that couldn't be expressed as fractions, shocked the Pythagoreans so much that they kept it secret, as it conflicted with their belief that all reality could be expressed through whole numbers and ratios. The realization that numbers could be infinite and unpredictable was terrifying, and yet it was one of the first steps toward modern mathematics. But Pythagoras wasn't only interested in math and science. He believed that numbers had moral and mystical significance. He taught that the number 1 represented unity and origin, 2 represented duality and conflict, and so on. His philosophy was a blend of logic and symbolism, reason and ritual. He believed in the transmigration of souls, that the human soul was eternal and could be reborn, and that living a pure life, guided by knowledge and discipline, could lead to spiritual liberation. Though much of what we know about Pythagoras comes from later sources, since he himself left no written texts, his impact is undeniable. His ideas influenced Plato, whose own theories of ideal forms were deeply shaped by Pythagorean thought. From Plato, the ideas filtered into Western science, mathematics, and philosophy, helping lay the foundation of rational thought. Pythagoras didn't conduct experiments in the way we understand science today. He didn't write down laws of motion or peer through telescopes. But what he did was perhaps even more important. He showed that reality could be understood not just by the senses, but through the mind, through reason, patterns, and numbers. He saw a deeper structure to the world, one that lay beneath the surface, hidden in the rhythm of music and the geometry of space. He taught that mathematics was not cold or mechanical, but filled with meaning, a divine language whispered by the universe itself. And in doing so, he transformed numbers from mere counting tools into keys that could unlock the secrets of existence. Centuries after the first sparks of rational thinking were lit by Thales and shaped by Pythagoras, one man came along who didn't just ask questions about the universe. He tried to classify, organize, and explain everything in it. His name was Aristotle, and to many, he was the most influential mind of the ancient world. Born in 384 BCE in the city of Sagira in northern Greece, Aristotle would grow to become a philosopher, a biologist, a physicist, a logician, and the father of systematic observation. While his teacher Plato imagined a world of ideal forms beyond our senses, Aristotle focused on the world we could see, touch, and study. For him, knowledge was not abstract. It was physical, real, and discoverable through careful analysis. Aristotle's brilliance lay in his method. He was obsessed with categorizing everything he encountered: animals, plants, politics, ethics, logic, even human behavior. He believed that to understand something, one had to observe it, compare it, and then deduce conclusions from what was seen. In an age still deeply influenced by myth and abstract philosophy, this was a revolutionary approach. He didn't want to simply speculate. He wanted to know how things actually worked. One of his most lasting contributions was in biology. Aristotle studied hundreds of animal species, dissected marine creatures, and carefully documented their anatomy, behavior, and reproduction. He noticed patterns, like how certain animals gave live birth while others laid eggs, or how some fish had lungs and others didn't. His observations led to one of the first attempts to classify living organisms. He grouped animals by characteristics, such as blood type, method of reproduction, or environment. Though modern biology has refined and restructured his categories, the spirit of his system, organizing life based on shared traits, still exists in scientific classification today. He also wrote extensively on physics, though his theories were based more on observation than experiment. For example, Aristotle believed that heavier objects fall faster than lighter ones. We now know that's incorrect, thanks to Galileo centuries later. But the point isn't whether Aristotle was always right. The point is that he tried to find patterns in nature and explain them with logic, not myth, not superstition. In doing so, he laid the groundwork for empirical science, the idea that truth can be uncovered by watching how the world behaves. Aristotle's influence wasn't limited to the natural sciences. He also invented formal logic, a system of reasoning that would dominate Western thought for over 1,000 years. He introduced syllogisms, deductive reasoning, and principles of valid argumentation. These tools became the foundation of rational debate, used not just in philosophy, but later in mathematics, law, and science. When you connect ideas like, all humans are mortal, Socrates is human, therefore, Socrates is mortal, you're using Aristotle's system. His work extended into ethics and politics as well. He believed the goal of human life was to achieve eudaimonia, often translated as flourishing or the good life. For Aristotle, that didn't mean pleasure or wealth. It meant living a balanced life, using reason and fulfilling one's potential. He saw humans as social beings, meant to live in communities and governed by justice and rational law. These views would shape political philosophy for centuries, influencing thinkers from Thomas Aquinas to the framers of modern democracies. What made Aristotle truly unique was how he blended logic with observation. Unlike his predecessors who focused heavily on the metaphysical or abstract, Aristotle was grounded in the physical world. He believed that truth began with the senses, that we must see, hear, feel, and measure the world before we can understand it. He took the raw material of the universe, animals, rocks, stars, cities, friendships, and tried to understand their causes, their purposes, and their connections. His writings, compiled into books like Nicomachean Ethics, Politics, Poetics, Metaphysics, and On the Heavens, became the core curriculum of intellectual life for over a millennium. In the Islamic Golden Age, his works were preserved, translated, and expanded upon by great Muslim scholars like Avicenna and Averroes. In medieval Europe, Aristotle's ideas were so dominant that he was referred to simply as the philosopher. And yet, Aristotle wasn't perfect. Some of his scientific conclusions were wrong. He believed the earth was at the center of the universe. He thought men had more teeth than women. He underestimated the power of experimentation. But what matters is not that he made mistakes. It's that he created a framework, a method, and a mindset that empowered future generations to refine, challenge, and expand on his work. In science, progress is made not by having all the right answers, but by asking the right questions. And no one in ancient history asked more meaningful questions than Aristotle. He turned curiosity into a discipline. He made the chaotic world seem organized and knowable. He believed that the pursuit of knowledge was not only noble, but essential to what it means to be human. And in doing so, Aristotle didn't just observe the world. He changed how the world observes itself. When we ask who was the first scientist in history, the answer is not as simple as naming one man. The roots of science stretch across continents, cultures, and centuries. From the temples of ancient Egypt to the city-states of Greece, from the deserts of Mesopotamia to the riverbanks of the Indus Valley, the human mind has always searched for answers, not just through faith or myth, but through observation, logic, and trial. Science, as we understand today, did not appear in a single flash. It evolved layer by layer through the efforts of countless thinkers who looked at the stars, at the human body, at nature, and asked, why does this happen? And more importantly, how can I prove it? That's what ties together all the ancient minds we've seen. Imhotep, who used logic and healing in a world of gods. Thales, who searched for natural causes behind cosmic events. Pythagoras, who saw numbers and harmony in the fabric of reality. And Aristotle, who built a system out of observation and reason. These men lived centuries apart and spoke different languages. Their ideas didn't always align. Some of them were wrong. Some were mystics, some philosophers, and some would be more at home in temples than in laboratories. Yet all of them shared one thing. They believed the world could be understood by human reason. Science was never the invention of one civilization or a single moment in time. It wasn't created in a lab or declared by a king. It was built by hands that carved stone, by eyes that watched the skies, by minds that dared to question what everyone else accepted without hesitation. And just as these early thinkers laid the foundation, future civilizations would take the torch further. The mathematicians of India, the astronomers of Persia, the engineers of China, the Muslim polymaths of the Golden Age like Ibn al-Haytham and al-Biruni, the alchemists of Europe, who became the chemists of the Renaissance, and the revolutionaries of the scientific revolution like Galileo, Newton, and Kepler. But what truly makes someone a scientist is not where they're from or what tools they have. It's the mindset. A scientist is someone who doesn't stop at because it just is. A scientist digs deeper. A scientist accepts uncertainty, seeks evidence, and tries again and again until pieces of nature's puzzle begin to fit. That mindset existed long before modern science had a name. The spirit of science, the willingness to ask questions, to be wrong, to challenge authority, and to seek truth, is far older than the microscope or the telescope. It's important to understand that early science did not look like today's science. There were no peer-reviewed journals or computer models. There were no advanced technologies, no modern universities, no standardized equations. But there was thought, there was wonder, there was discipline, and most of all, there was courage. The courage to think differently, to risk being ridiculed or punished, and to follow reason instead of rituals. In that sense, the earliest scientists were also rebels, pioneers, and visionaries. What we call science today is a result of this long, messy, and magnificent journey. It's built on curiosity, but also on collaboration. Each thinker stands on the shoulders of those who came before. Imhotep may not have known Thales, who never met Pythagoras, who didn't live to read Aristotle. But through history, their ideas flowed into one another, each one adding a piece to the great mosaic of human knowledge. The beauty of science is that it belongs to no one and yet to everyone. It crosses borders, religions, and eras. It evolved with each generation, improving itself through testing, failure, correction, and discovery. It's not frozen in time. It's alive, growing every time someone, somewhere, stops to wonder how the world works. So maybe the question isn't, who was the first scientist? Maybe the real question is, where does science begin? And the answer might be simpler than we think. Science begins the moment we stop blindly accepting and start curiously observing. It begins with a question. It begins with doubt. It begins with wonder. And in that sense, the spirit of the first scientist lives on, not just in labs or lecture halls, but in anyone who looks up at the night sky and wonders what lies beyond, who listens to the rhythm of the world and searches for the pattern, who believes that truth is worth pursuing even when it's hard. Because science isn't just a method. It's a mindset. It's a legacy. And it's yours to carry forward. From ancient Egypt to classical Greece, from temples carved in stone to minds lit by stars, science wasn't born in a moment. It evolved through observation, curiosity, and the courage to question the unknown. The first scientist might not have had a microscope, but he had a vision to understand the universe not through myth, but through reason. And maybe that same spark lives in you. Because science isn't just in labs. It begins with a single question. Why? Backhand index pointing right, if you're ready to uncover more truths hidden beneath history. Subscribe to History Vault, where forgotten geniuses come back to life.